Okay, in this podcast we're going to talk about limiting reactants. Alright, so let's talk about what that means. So, let's say we have a manager of a deli. He's ordered 13.6 pounds of meat, 15.5 pounds of cheese, and he has 50 loaves of bread. And we remember the conversions we have for how much a slice of meat and cheese weigh. So the question is, how many sandwiches can he make? What does he have left over? And which ingredients will limit how much he can make? Okay, so let's take a look. So if you recall, we have this equation that we're using that says 2 bread, 3 meat, 1 cheese give us 1 sandwich. And what he's saying is we've got this quantity of our ingredients. So what we need to do is figure out, based on each ingredient, how many sandwiches we can make. Okay? So I'm going to take them one at a time and go 13.6 pounds of meat. Whoops. And what I know is 0.0750 pounds is 1 meat. And I know I need 3 meats for 1 bread, meat, and cheese sandwich. So if I multiply that out, that's going to give me, based on this, I'm going to get 60.4 or 60 sandwiches. Okay? 60 sandwiches. Now let's take 15.5 pounds of cheese. So I'm going to take 15.5 pounds of cheese, and what I know is 0.10 pounds of cheese is 1 slice of cheese, and then I need 1 slice of cheese for 1 bread, meat, and cheese, and cheese sandwich. And so that's going to take me, that's going to give me 155 sandwiches, right? And then I take my, let me see, he's got 50 loaves of bread, 50 loaves of bread, and what I know is 1 loaf is 20 slices, and what I know is I need 2 bread for 1 sandwich. Okay. So this is going to give me 50 times 20 divided by 2. So it's going to give me 500 sandwiches. Right? Okay. So if we look at this, I have enough meat for 60 sandwiches. I have enough cheese for 155 sandwiches. And I have enough loaves for 500 sandwiches. So what I'm going to make is 60 sandwiches. Okay, when the question is what ingredient limits how much we can make, the answer is that it's the meat. I'm limited by how much meat I have. Okay, I can only make 60 sandwiches. And then the next, alright, so now we're going to answer the question of what does he have left over. So we know that all the meat's been used because that was the limiting reactant, right? So we're going to figure out how much extra cheese and how much extra bread. So what we know from the last last part, was that we made 60 sandwiches, right? I'm just going to call these sandwiches a little bit easier, right? And for cheese, what I know is for 1 sandwich I need 1 cheese. And that 1 piece of cheese weighs 0.100 pounds. So what this means is I need 6.0 pounds of cheese. And if I need 6 and I started with 15.5, I subtracted 2, and I get that I have 9.5 pounds of cheese left over. And for bread, if I have 60 sandwiches, what I know is that 1 sandwich takes 2 bread, and that there are 20 pieces of bread in 1 loaf. Not a loaf, but a loaf. So this means I will need, let me see, 6 loaves. If I have 50 loaves minus 6, I'm going to have 44 left over. Okay, so let's take a look at a real problem. Alright, so a limiting reactant is the reactant that limits how much of something we can make. The excess reactant is the reactant that you have left over at the end. Sometimes there's one, or sometimes there's more than one. So if we think about this example, a bike maker has 25 wheels, 17 frames, 11 handlebars. The question is, how many bikes can they make? So if I have 25 wheels, what I know is 2 wheels make 1 bike, so I can make 12 bikes, right? 12 and a half, but I can't really make 12 and a half. I got 17 frames, and I know there's 1 frame gives me 1 bike, so that means I can make 17 bikes from the frames. And if I have 11 handlebars, and I'm assuming this is a set, 1 handlebar for 1 bike, so I can make 11 bikes. So the limiting reactant is my wheels. The excess reactants, things I have left over, are going to be my frame and my handlebar. Suppose that we have 4 molecules of hydrogen and 5 of oxygen. Draw a picture that represents the container before and after the reaction to make water. So I got 4 hydrogen. I'm just going to use X's for hydrogens. 1, 2, 3, 4, 5 hydrogen. 1, 2, 3, 4, 5. And afterwards I make water. So let me see. I need a hydrogen, oxygen, hydrogen. Whoops. And once I've done that, I've used all my hydrogens. 1, 2, 3, 4 pairs. I've used 1, 2, 3, 4 oxygen atoms, which leaves this left over. So I also have this in my container at the end. Okay. So I can also solve this in a factor-label way, and I can do that by writing the equation. I've got hydrogen and oxygen gives me water. And let me see, I need 2 of these and then 2 of these. So determine how many water molecules I can make from each reactant. So if I have 4 molecules of hydrogen and I know 2 molecules of hydrogen give me 2 molecules of water, I know I'm going to have 4 molecules of water. And the question is how much excess reactant is left over. So let's just see how much I get from 5 molecules of oxygen. 5 molecules of oxygen, and what I know is it takes 1 molecule of oxygen, right, for every 2 molecules of water, which is 10 molecules of water. So what this tells me is that the limiting reactant is the water, the excess reactant, the limiting reactant is the hydrogen, the excess reactant is oxygen. And the question is, how many do I have left over? So if I make the 4 waters that I can make using the hydrogen, let's say I take 4 waters, what I know is 2 waters require 1 oxygen. 4 times 1 divided by 2 is I need 2 oxygen. And if I started with 5 and I need 2, I'm going to have 3 oxygen molecules left. Alright. Let's keep going and take a look at a real problem. Alright. Here I have potassium superoxide, KO2, is used in breathing gas mass to generate oxygen by this reaction. If the reaction vessel has 125 grams of potassium superoxide, 45 grams of water, what mass of oxygen can be produced, and what mass of excess reactant will be left over? Alright, let's do this here. So I'm starting off, I've got 2 reactants, and what I need to do is determine how much each of these can make, how much oxygen each of them can make. So I'm going to do it one at a time. 125 grams of potassium oxide is my given, and if I have that, what I've determined is my molar mass of potassium oxide is 71.1 grams of potassium oxide, gives me 1 mole of potassium, KO2. And for every 4 moles of KO2, I can make 3 moles of O2. But it's asking me about grams, so I know 1 mole of O2 is 32.0 grams of oxygen. So I plug and I chug, make sure I can cancel everything out, moles of oxygen, and I get, let me just put this up here, 42.2 grams of oxygen, of O2. I'm going to do the same thing here using my 45 grams of water. If I have 45 grams of water, what I know is 18.02 grams of water is 1 mole of water, and that 2 moles of water produce, 3 moles of oxygen. And again, 1 mole of oxygen is 32.0 grams of oxygen. If I plug and I chug on this one, I'm going to get, it's 119.9 or 120 because I want 2 sig figs, 120 grams of oxygen. So, what mass of reactant is left over? So first of all, the limiting reactant is going to be my reactant that gives me this. So this is going to be my potassium oxide, and I'm going to have an excess reactant of water. So what mass of excess reactant is left over? So what I'm going to do is I'm going to say I can make this much oxygen, 42.2 grams of oxygen, and what I know is 32 grams of oxygen is 1 mole of oxygen, and that I get 3 moles of oxygen for, I'm trying to figure out water, for 2 moles of water, that's my excess, and that 1 mole of water is 18.02 grams of water. When I do that, I get that I need 15.8 grams of water. Now if I had 45 grams of water, 45 minus 15.8 grams that I actually used means I'm going to have 29 grams of water left over. Okay, we're going to stop there.